Alright, I want to go over the density homework because almost everyone felt it. So, what is so remember that density is equal to mass divided by volume. So, make sure you read instructions. 1. You need to show work on everything. You just hand in a number, I'm not going to accept it anymore. Secondly, uh, remember that this is supposed to be individual work. You are not allowed to copy other people's answers. On some of the homework, I noticed there was a trend where there was the same wrong answer on a lot of people's homework. There is no reason for that answer to have been gotten other than by someone leaving off a period. But then everyone else also left off a period, which made no sense at all unless they copied. If I catch that again, it's going to be a 0 for both you and who you copied off of. And you have to show all work. So, what is the density of an object with a mass of 34 grams? That's the mass. And a volume of 13 cubic centimeters. Another thing the directions say is unless otherwise stated, use appropriate significant figures. So our mass is 34 grams and our volume is 13 cubic centimeters. So density would equal mass divided by volume. Our mass was 34 grams and 13.0 cubic centimeters as our volume. This would give us 2.615385 grams per cubic centimeter. But we need to use appropriate significant figures. This has 2, this has 3, division, so we would round this to 2.6 grams per cubic centimeter. Because this has 2, that has 3. So this class requires algebra. We will be using a lot of algebra in this class. So what is the volume of a liquid with density? So this is density and a mass of 78 grams. So this is the mass. So density is equal to mass divided by volume. And we're trying to solve for volume. To solve for volume, we multiply both sides by v. That cancels out on the right side. So we get volume times density is equal to mass. To get volume by itself, we divide by density to both sides. Cancels density on the left side. So volume is equal to mass divided by density. Mass is 78 grams. Density is 1.5 grams per liter. And we get an answer of 52 liters. The grams cancel each other out. So now we need to check for significant figures. This has 2. That has 2. This is already rounded to 2 significant figures. So it would be 52 liters. I took 2 points off if you didn't follow these directions, and rounds to significant figures are what the problem said to do. So number 3, we have a density and we have a volume. We're trying to solve for mass. So density is equal to mass divided by volume. Solving for mass, we multiply volume to both sides. Gets rid of it on the right side. So we see that mass is equal to volume times density. Volume was 48 cubic centimeters. density was 5.7 grams per cubic centimeter, and that's equal to 273.6 grams. The instructions say round to nearest whole number, so 274 grams. The density of lead, that, and we have a volume of 91 grams. So we have a mass. How much volume? So remember, solving using algebra, we got that volume was equal to mass divided by density. Our mass is 91 grams. Our density is 11.4 grams per cubic centimeter. Grams cancel out, and this is cubic centimeters, and we get an answer of 7.9824456 grams per cubic centimeter. And just cubic centimeter. But it says round to two significant figures. That's what we need to do anyway. So that's equal to 8.0 cubic centimeters. Alright, so 1 milliliter of water has a mass of 1 gram. We can immediately stop right here. So we have density is equal to mass divided by volume. We have a mass of 1 gram and a volume of 1 milliliter. So the density of water is 1 gram per milliliter. Does density change on the amount we have? Is it intensive or extensive? Is density intensive? It doesn't matter on the amount of mass we have. So what is the density of water? Well, it's always going to be 1 gram per milliliter. So what is the mass of liquid with a volume of 58 milliliters? We got 58 milliliters as a volume and a density of 2 grams per milliliter. So that's density. So mass, so starting with our original equation, mass would be equal to density times volume. So 2.4 grams per milliliter times a volume of 58 milliliters. That gives us 139.2 grams. And then it says use appropriate sig fig. So this has 2. We're using multiplication. And this has 2. So we need to round it to 140. Calculate the volume of an object that has a density of 0.7 grams per cubic centimeter and a mass of 19 grams. Density. That's their mass. So volume is equal to mass divided by density. So 19 grams divided by 0.70 grams per cubic centimeter. And so this is equal to 27.143 cubic centimeters. This has 2 sig. 2 sig, so we need to round this 27 cubic centimeter. So this is the amount of work you should be showing. You need to be showing your starting equation if you're using an equation. You show when you plug it in, and then you write out. One thing I should note, exact numbers, i.e. non-measured, non-measured values have infinite significant digits. Significant figures. So what I mean by this is if I tell you there are 60 minutes in an hour, that does not mean that you should round everything to one significant figure if you use 60 minutes. Because that is the definition of an hour. An hour is exactly 60 minutes. We know this to an infinite number of places. It's by definition 60 minutes. A minute is 60 seconds. We know this exactly. Now, if I use a stopwatch and I measured, it took about 59, 60 seconds, then you're estimating the time and actually measuring your time. So if you measure something, that's when significant figures come in. Significant figures are meant for measured values where you have some degree of uncertainty. I haven't told you all this, but liter is actually defined in such a way that true water should have 1 gram per milliliter. The definition has changed, but this, we're using old definitions. This is technically exact. I didn't take off for points if you didn't know that, because I didn't tell you that. But treating water as having 1 gram per milliliter, we treat this as not measured but exact. Real water you'd actually use will be varied off. It also depends on temperature. But we technically treat how we figured out the size of a liter was based on the definition of water at one point. Now it's based on cubic centimeters and change, but anyway, it didn't matter. What you're supposed to gather from this problem is that the density of water is 1 gram per milliliter, and I'm asking you what the mass of 34 milliliters of water was. I think I put on people's papers 34, but you could have rounded it to one significant figure, 30 milliliters, and one of them is fine. So if you use appropriate sig fig, the mass is 34 grams, and so finding volume is equal to mass divided by, no, we're solving for mass. Mass is equal to volume times density. So volume is 34 milliliters. Mass is 1 gram per milliliter. So we get an answer of 34 grams. But putting appropriate figures on this would be 30 grams, technically. If you did appropriate significant figures. Because y'all wouldn't have known that this should be treated as that. So using appropriate sig fig, 30 would have been a good answer. I didn't take off if you put 34 grams. Determine the mass of an object with a volume of 82 milliliters and a density of 0.0041 grams per liter. This is very important. In this class, we mix units all the time. This is in liters. This is in milliliters. You have to pay attention to units as I change them up constantly. So our volume is actually 0.082 liters. We need to convert units to make them match up before we plug them into an equation. Or density is 0.0041 grams per liter. and plugging it in, we get a mass, just these multiplied together, a mass of 3.362 times 10 to the negative 4 grams. And using appropriate sig fig, this has 2, that has 2, so 3.4 times 10 to the negative 4 grams. Problem 10, same thing, we have milliliters and we have liters. So we take our volume and convert it to liters, 0.106 liters. Our mass is 44 grams, so density would be 44 grams divided by 0.1. And when you make your points, make them bold, or at least not a tiny little dot like that. You can't even see it, it's on the screen. And so this is equal to 415.09 grams per liter. Converting this into scientific notation, it's and using appropriate significant figures, or it says use 2. So use 2 significant figures. So that'd be 4.2 times 10 to the second grams per liter. Especially in the other class, I saw this answer a lot. 420 times 10 square grams per liter. What I'm assuming happened is someone didn't put a decimal point, or they put it so small you couldn't see it, and a lot of people copied. So again, if I catch you copying, it's going to be an automatic 0 on the whole thing. There is no reason for every single person to leave off this period. It made no sense. Because 10 to the squared is 100, so 420 times 100 is not anywhere near 415. That clear up density? Y'all think I got it? Alright, let's do some significant figures. Some questions the other class asked. So for example, like number 10. Number 10, it says Lake Michigan holds 1.3 times 10 to the 15 gallons of water. If just Chicago removed water from the lake and it never rained again, how many days would the water last? Chicago uses 1.2 times 10 to the 9 gallons of water per day. So you begin by starting with a given number. Usually you don't use a ratio. You start with a non-ratio number. So we would start with 1.3 times 10 to the 15 gallons of water. And we're trying to get to how many days. We're trying to get somewhere an answer equal to days. So we need to get rid of gallons and just have days. We're given a conversion factor. This conversion factor is 1.2 times 10 to the 9 gallons per 1 day. We can also flip that as 1 day, Chicago uses 1.2 times 10 to the 9 gallons. And again, we would insert into this equation whichever one will cancel out gallons and give us days. So we would insert this one into it. 1.2 times 10 to the 9 gallons. So it cancels out gallons, and we put 1 day on top. At this point, I will give the code word. Code word is derivative. And for remote learners, the code word is derivative. So dimensional analysis is very important. It's one of the most important things I learned from college. In that I use it for every single thing. Whenever I'm doing calculations. So if I didn't have a calculator, or I should say, if I didn't have Google, and I needed to convert something like kilometers per hour into miles per hour, this is what I would do. I know how to convert between imperial units. I know they're like 12 inches in a foot. I know that there are 5,280 feet in a mile. That's the, I know how to convert that. I know how to convert between metric units. 1 kilometer is equal to 1,000 meters. So I know my imperial unit conversions by heart because I grew up in America. Everyone that grows up here should know that there are 5,280 feet in a meter. There are 3 feet in a yard. There are 12 inches in a foot. You should be have used that throughout your life, or at least seen it. The only conversion factor I know between metric and imperial unit is this one. 1 inch is equal to 2.54 centimeters exactly. That is the definition of an inch. The United States actually uses the metric system. We as people don't normally use it though. No, it's black. It's red. It's just the screen and lighting is making it darker. This is the only conversion factor I know. I don't have it memorized any other notation. I don't know how many meters are in a foot or how many feet are in a meter. I don't know anything else but this one. This is the definition. 1 inch is equal to 2.54 centimeters. So if I didn't have Google and I couldn't just Google how 55 kilometers per hour, miles per hour, I would. So if I'm trying to convert 55 kilometers per hour to miles per hour, this is the way I would do it by hand. I have 1 kilometer, or 55 kilometers per 1 hour, and I need to convert kilometers into something else. So I will convert it into meters. So 1 kilometer is equal to 1,000 meters. I know that I need to now convert meters. So first, kilometers cancel each other out. So now I'm in meters per hour. I need to convert meters. So the only conversion I know is centimeters. So I'm going to convert meters into centimeters. So I would either do 1 meter is equal to 100 centimeters. So I'd either plug in 1 meter divided by 100 centimeters, or 100 centimeters is equal to 1 meter. If I want to cancel out meters, so I would put 1 meter on bottom, 100 centimeters on top. I am now in centimeters per hour. And you can see this is quite a big number on top. Because if you're moving at 55 kilometers per hour, centimeters per hour is going to be quite large. Now I can add in my conversion factor. I need to cancel out centimeters and convert it into inches. So 2.54 centimeters equal to 1 inch. And now I'm in the imperial unit. So I can cancel out centimeters. I have inches per hour. Now that I'm in imperial, I can use my imperial conversions. There's 12 inches to 1 foot. And there are 5,280 feet in 1 mile. So feet cancel out, inches cancel out, and I'm left with miles per hour. You can leave ones off because 1 times anything is just anything. So this is 55 times 1,000 times 100. divided by 2.54 times 12 times 5,280. And that is equal to 34.1754 miles per hour. Or you can abbreviate it as NPH, and that would be the only time you abbreviate the unit like that. If I were to do significant figures, this number has two significant figures, but note all these other ones, 100 meters and a kilometer, that has infinite significant figures. 100 centimeters and 1 meter, infinite. 1 inch to 2.54, this turns out to be exact. This is the definition of an inch, so that has infinite. 1 foot is equal to 12 inches, that's infinite, and this is infinite too. So when doing multiplication and division, we choose the lowest one, which is 2. 2 is much smaller than infinity. So we would round this to 34 miles per hour. And again, on the homework, I said you didn't have to do significant figures on that because the point of it was making sure you understood how to do significant figures. This is literally how I convert kilometers per hour to miles per hour. If I didn't have Google and couldn't Google miles, 55 kilometers per hour to miles per hour. You could also use Google and memorize the conversion factor. So kilometer to miles. If you memorize the conversion factor, 1 kilometer is equal to 0.621371 miles. This number is often not used. It's more often used that 1.60934 kilometers is equal to 1 mile. We usually try to make whatever number, we try to avoid using less than 1 conversion factors. So you can remember this, that a mile is approximately equal to 1.61. Note that this isn't exact. This is non-exact, so it has 1, 2, 3, 4, 5, 6 significant figures. So we could put in 55 kilometers per 1 hour. And we need to convert kilometers into miles, so we come over here and put kilometers into miles and plug one of these in. It doesn't matter which one you use, they both come out the same. I'm going to use this one, 1.60934, and to 1 mile. If you plug that in, you'll also get the 34.1754 miles per hour. This has 6 significant figures. This has 2. We use the one that has the least, so 34 miles per hour, and we get the same result. If you had rounded this to 1.61, then you would reduce significant figures down. So normally we're converting one unit to another unit. We can also convert a ratio into another ratio. So for example, 50 miles per hour to feet per second. So we begin with starting with whatever we're given. We usually try to not begin with a ratio, but if we're converting a ratio to another ratio, we have to. So this is 50 miles per 1 hour. We can approach this in multiple different ways. We have to convert miles into feet and hours into seconds. It doesn't matter which way you do it. Let's start with miles. So we know that 1 mile is equal to 5,280 feet. So miles cancel out. So now we're in feet per hour. We want it in feet per second. So 1 hour is equal to 60 minutes. And 1 minute is equal to 60 seconds. So minutes cancel out. Hours cancel out. So we're left with feet per second. So this would be 50 times 5,280 divided by 60 times 60. And that's 73.3 carried feet per second. Another thing you could have done, yeah, 30 carried, repeating. Now you got me questioning if that's the right term for it. 3 repeating, but I always thought it was carried. It's technically 3 repeating, but so if you had memorized this, that 1 hour is equal to 3,600 seconds. So you had that memorized, we could have reduced this conversion a little bit. So converting 50 miles per hour, we can plug this in. So let's do time first. So 1 hour is equal to 3,600 seconds. So hours cancel out. We're now in miles per second. Now we can add a conversion factor of 5,280 feet divided by 1 mile. The miles cancel each other out, giving us feet per second. And this gives us the same thing. 50 times 5,280 divided by 60 times 60. And that gives you the same thing, 73.3 repeating. Again, this is the minimum work you need to be showing. I guess you could leave this portion off, but you need to be showing this grid. I'd like you to show the entire process, but I need to be able to see where you're plugging in numbers. The first one, it's not hurricane. First are tropical depression, but the first one is not expected to become a hurricane. The other one is several days away. Now, no, Marco was the other one. Um, so let's look at a problem like 15. So it says a projectile travels 3.00 times 10 to the 3 feet in 1 second. So this is relating feet to seconds. How far will it travel in 18 minutes? So it then tells you another number. We usually begin without a ratio. So 18 minutes. No, we can't use this ratio right now to cancel it out. You can go ahead and plug this in by one. This is a minute, and this ratio is the second. So I would first begin by converting the minutes into seconds. So 1 minute to 60 seconds. Minutes cancel out, and we're now in seconds. Now we can convert feet into seconds or seconds into feet. So we know it's 3 times 10 to 3 feet in 1 second. Seconds cancel out, and now we're in feet, which is what the question says, how far. Another way you could have done this, which I do not recommend, is we could have began with the 18 minutes, then we add our conversion factor in. You really don't know which way to add the conversion factor. We know minutes is on top, and we need to put the time unit on bottom. Again, I don't do this. I use the conversion first. Now we're in minutes, feet, and seconds. We want to cancel out minutes and seconds. So we would add in, cancel out the minutes. We do a minute here, and we do a 60 seconds on top. The seconds cancel out, the minutes cancel out, and we're just in feet. I'd say do not do this. You should immediately convert before you plug in your given conversion factor. Are there any questions? So I'm extending the homework by 1 day because a lot of people try turning it in without showing any work. No, the dimensional analysis. You already finished it and you did all the work. You can turn it in if you want. Are there any questions?